Hi everyone, today we are going to discuss our practice paper 11. So this paper contains 10 MCQs and a essay question from chemical calculations. Okay, so this is targeted actually your first term test for grade 12 students, which can come unit 1, unit 2 and unit 3, atomic structure, bonding and then chemical calculations. So those are the lessons we are focusing here. So let me show you the questions. These are the MCQs we are going to discuss, and this is the essay. Okay, right. So this is the final paper of a paper series we were covering those three lessons I mentioned. Right. So let's start from the first MCQ. So it's actually labeled as 11 because there was a practice paper 10-9 also. So these questions are like ABCD type questions. So if you go to the 11th question, you can see it's asking the correct statement regarding the structure of the following compound, right? So there is a compound, and you can see that 3 carbon atoms of that compound is labeled, okay, X, Y, Z. So let's see what are the statements. Carbon atom labeled X, Y, and Z lie on the same straight line, lie on a straight line. So we have to check whether that is true. Okay, so in order to do that, let's draw that one in a way that it represents the bond angle. So then only we can see whether they are on the same straight line or not. Okay, so now you can think the 3 carbon atoms here. If you take this X, it is you can see there are 2 repulsion units around that one, the triple bond and the single bond made with the hydrogen. Okay, so then it's supposed to be sp hybridized. Okay, and this Y carbon also the same, sp hybridized, and Z carbon, there are 3 repulsion units around that Z carbon, so you have sp2 hybridized carbon here. Okay, so depending on the number of repulsion units we can decide the hybridization, you all know that. Okay, right. So if you draw that, then this is the X carbon, right, and then here you have your Y carbon and Z carbon. So let me show you how bond angles are come into play here, right? So now you can see there are 2 repulsion units now. So the triple bond act as a 1 repulsion unit. Okay, so then the if you want to keep them apart as much as possible, the repulsion unit, they contain electrons now. Electrons repel from each other, right? So if you want to keep the maximum distance among them, you have to keep them in an angle of 180 degrees. Okay, and then if you consider the other carbon atom Y, that also should contain 180 degree angle, because there are also 2 repulsion units. But if you go to the Z carbon, so there are 3 repulsion units. So in the plane, if you want to keep them apart, you have to keep like 120 angle each, 120 degrees. Understood? So depending on these things, we can give a name for their electron pair geometries, or we can say here shapes too. So this X carbon is a linear geometry, and your Y carbon is also linear geometry and shape here, and this one is trigonal planar geometry. Okay, so then these all atoms are in the same plane, no, isn't it? So the including hydrogen and oxygen, even they all in the same plane. And as it is mentioned in the first statement, XYZ carbon atoms are also lying in the same straight line, isn't it, Lama? So here's what we're going to memorize. Okay, here's what we're going to memorize. If you notice, sp hybridized atoms, okay, sp hybridized atoms and their connected atoms, they lie in the same straight line, isn't it? Sp hybridized atoms and the atoms connected to that, so that means this hydrogen and this other carbon, they all should lie in the same straight line. That is the theory. Okay, and then the other one, if you consider about the same plane, it includes sp and sp2 hybridized atoms as well. sp and sp2 hybridized atoms and the atoms connected to that, they all lie in the same plane. Understand? So if you consider the same plane concept, you can include two more atoms to the same plane. So they all lie here in the same plane. You can see because this Z carbon is sp2 hybridized. So the oxygen and hydrogen are connected to that. Okay, so I'm going to write that one here. Sp and sp2 hybridized atoms and connected atoms lie on the same plane. Then you can see about the same straight line thing. We can say sp atoms and they are connected atoms lie on the same plane, same straight line. Okay, I hope you understand about the same line and same plane concept. You have to check whether the hybridization or you can go with the geometry shape and decide whether they are in the same line or same plane. And this is a very common MCQ point in our papers. Right. So now you can see they all lie in the same straight line, the carbon atom. So the first statement is true. And the second one is also going to be true because all above atoms are lie on the same plane. So then first two statements are correct depending on the theory we just reviewed. Okay. Now let's go to the statement C. So in these type of questions we should not be hurry to select a response because there are two other statements. You have to examine them as well because if in case if one of them was true, answer is going to be 5. Okay, so you have to be careful. So if you go to the first C statement, the electronegativity of labeled carbon atom increases as Z, Y and X. Okay, so now they are asking for the electronegativity. If you go to these atoms, so we are comparing carbon atoms. Okay, we are comparing the atoms of same element. Okay, so you can compare the carbon atoms of same element. So in this case we need to check these four things. Okay, what are those things? In the mnemonic scope we remember that one. Okay, we have to apply electronegativity of labeled carbon atoms. You have to follow scope. What is this scope? Scope is percentage, charge, oxidation number and peripheral atom electronegativity. So you have to check these four in order to examine whether the electronegativity variation of X, Y, Z. Understood? So now let's we have found the S percentage here, and if you go to the S percentage of this sp atom, it is 50% S percentage is there because there are two orbitals participated for hybridization and one is S, and this is also 50% S character, and this is 33.3% S character because out of the three orbitals participated for hybridization, one is S. Okay, 50-50 and 33. And you can see now the lowest S character is there for Z, and then Z should be the lowest electronegative atom. Okay, Z should be the lowest electronegative atom. Is that clear? Okay, so Z should be the lowest electronegative atom. Now we have to go for the when they have the same S percentage. Okay, we have to check the next point. It is charge. Okay, so if you check there is no charge for X and Y, so then we have to go to the next point, which is oxidation number. If you check the oxidation number here in this carbon, it is gaining partially electron from hydrogen, so then its oxidation number is -1 and there is no electron exchange among carbon. Okay, and if the theory applied here, it's all bonded to carbon atoms, so its oxidation number is going to be 0. Okay, so -1 and 0. Now you can see a difference, right? So the one with the higher oxidation number Y should have the higher electronegativity. and one with the lower oxidation number should have the lower electronegativity. So the most electronegative one here would be Y. So now if you check the order, it is wrong because the last two are mixed up here. So then this C statement is false. Okay, like that you have to examine the electronegativities of same type, same element atoms. Okay, now let's go to D. The bond angle around the carbon atom labeled as X and Y are 180 degrees. X and Y, yeah, 180 degrees, and around the carbon atom labeled Z is exactly 120. Even though I labeled that as 120, so telling exactly 120 is wrong, isn't it? We can't say that one because why? You can see, we can see. I'll draw it again here. If you just draw the Z carbon atom only, we can clearly see their repulsion units. And here you can see it's a double bond. It's a double bond. Okay, so it is a double bond. So double bonds have double bond. So double bond has 4 electrons, and it must exert a greater repulsion. Understand? It should exert a greater repulsion on the other two bond pairs. Okay, so here just 2 electron bonds, only single bonds, and it should exert a greater repulsion, and the bond angles would be different than 120. So it will be around, let's say, 121 degrees, and this also going to be 121 degrees, and this should be 118 degrees. So it's not exactly 120. Telling exactly is wrong. So now you can see answer A, B correct. So they are asking for the correct statement. So answer is going to be answer 1. Okay, so that's how you take the answer for the 11th MCQ and the first MCQ of our today's paper. Right. Now we go to the 12th one. So 10 cubic centimeters of sodium sulfate solution is a chemical calculation question, and 2.13 grams of sodium contains 2.13 grams of sodium sulfate. Okay, so a mass is given and a volume is given regarding the sodium sulfate solution. Okay, so let's build a small diagram for that now. It will be helpful for us later. Here you have sodium sulfate, and volume is 100 cubic centimeters, and it contains 2.13 grams. Later we might need to find the moles, no, but in the question relative atomic masses are not given, so that's a mistake here. You must given the relative atomic masses. So sodium 23, sulfur 32, and carbon 12, oxygen 16. Okay, those data must be here. Okay, so let's assume we got it. And the other compound, other solution, there is a 200 cubic centimeter solution of sodium carbonate. 200, and it has dissolved 1.59 grams of that compound. Okay, so after mixing these two, so that means if you mix these two, you get a 300 cubic centimeter solution, and it both contains the two compounds, sodium sulfate and sodium carbonate, and they are telling you 100 cubic centimeters of this new solution was diluted to 500. Okay, now you are separating 100 cubic centimeters of this, and that means you are taking actually 1/3 of the solution. 1/3 of solution. Okay, so a separation here, and then you add water until it reaches now this is dilution. Add water until it reaches 500 cubic centimeters of solution. Okay, so they are asking statements regarding the final solution. That means right here, this is what they are interested. So now we have to think, we have to find the information proper ones from here, and we have to work on the problem and get to the final solution, because we know nothing about the final solution here except the volume. Okay, so we have to find the moles concentration whatsoever they're asking here. So you can check the statements briefly. They're asking for the concentration of sodium carbonate and sulfate for the final solution, and sodium sulfate concentration, sodium, like that. They're checking for the concentration. Concentration is moles over volume. So you have to divide the moles by the volume of the solution. So we need the moles, right? So we only know the masses of the two compounds. So we have to use the molar masses and find their moles. Okay, so let's try finding it. So sodium sulfate, the relative atomic masses sum here will be like 46 plus 32 plus 64. Okay, for oxygen 64. So it's going to be 142. Okay, 142. So you have to divide 2.13. That's a problem with my cursor. Okay, 2.13 by 142. Okay, so let's find out the answer. So it's not clearly seen as divisible, but if you try a bit, you can find. Okay, 2.13 division 142. It's like 0.15 or something as a range. 2.0.015. This is the number of moles of that compound. So in the same way, if you find sodium carbonate moles, we have to get the molar mass here, 23, 12 and 48. If you add them, you get 3, 1, 23 into 2, no? It's like 46. 46, 12 and 48. So 6, 106. Okay. So 1.59 division 106. That also going to give you the same number of moles, 0.015 moles. Okay. So now these two compounds, these number of moles are there in their respective solutions. Once you mix them together, same number of moles will be here. That means 0.015 from sodium sulfate and 0.015 from sodium carbonate. So don't find any concentration here because it is not necessary. Okay, and we have to pay attention to this separation here. So they separate 1/3 of the solution. Separate. So during separation, number of moles changes. Okay, number of moles changes. So here you will have 1/3 of each solute. So 0.005 from sodium sulfate and 0.005 same number of moles from sodium carbonate. Okay, and then next we are doing adding water. So that's dilution. So during dilution, number of moles doesn't change. Okay, dilution number of moles doesn't change, only the volume of the solution increases. Okay, so now the same number of moles, that means 0.05005 each, is contained in this solution. Okay, so now we're going to find the concentration for that one. Okay, so telling that concentration of these two things are different or twice, that is wrong, no? So we can, without even finding the concentration, we can say, see, the concentrations would be equal. So then let's find the concentration for one and see. 0.005 division 0.5. Okay, so the concentration is going to be 0.01 m. That is the concentration. So then that B statement is true. And sodium concentration, they are telling 0.04. We can agree with that one because I'm going to explain that here. Sodium sulfate contains 2 sodium ions, and sodium carbonate also contains 2 sodium ions. So if you just write and find how many sodium plus ions are there, how many moles, right? You will see, so each compound 0.005. So from here sodium will be coming like 0.01 sodium of sodium plus, and from this also you will have another 0.01 because each compound contains 2 sodium plus ions. Okay, so then if you add them up, 0.04. So if you divide by uh, yeah, so 0.02. Okay, so if you divide it by 0.5, then you will have 0.04. Or you can just think and tell, if the compound concentration is 0.01 and the sodium concentration should be 4 times like that, because each one has 2 sodium plus ions and the concentrations are equal. Okay, and thereby you can say the second one is wrong, sorry, the last one is wrong. Why? Because it's not 0.002, should be the concentration 0.001, sorry, 0.01 mole per decimeter cube concentration. Understand? Because it's carbonate concentration would be equal to sodium carbonate concentration. Okay, so I will write 2 chemical reactions which will help you to understand this further. So sodium sulfate breaks into 2 sodium plus ions and SO4 2 minus. Now you can see if there's one compound, there will be 2 sodium plus ions, right? And the same way we can say regarding sodium carbonate, 2 sodium plus and carbonate ion. Understood? This is how it goes. So the correct statements are B and C, then your answer would be 2. Okay, right. Now we're going to check the MCQ 13. What is the correct increasing order of the given property? So there are 4 things mentioned: electron affinity, first ionization energy, metallic lattice stability, okay, that means strength of the metallic bond they are checking, and then the boiling point. Okay, so let's quickly examine them and find out what is correct. So look at the first one. Electron affinity of these group 17 elements, we have discussed it several times. It increases in this way. Okay, chlorine is the one with the highest electron affinity for the group 17. So which is not a very common thing. We see them in order, no, usually, right? The most electronegative one is fluorine, but its electron affinity is lesser than chlorine, right? So the reason is, we have discussed this several times. You can check our previous recordings also. There will be more detailed explanations. Fluorine is small in size. Okay, so therefore taking a new electron is not that much likely to happen. Okay, but chlorine, you can see, its radius is a little bit higher than fluorine, and the nuclear attraction is also a good one. So chlorine is it having the optimum conditions. Okay, optimum conditions. So not too small, not too big. The problem with iodine and bromine is they are very big. That's why their affinity is low. So basically affinity means likeliness for the electrons. Okay, likeliness for the electrons. So here if you want to write a reaction, affinity means you can write, for the affinity we can say like the yeah, one second, affinity we can write F minus goes to Fn electron. So this is the reaction for the affinity. It's the reverse of first electron gain energy. Okay, so the likeliness to happen, this we check. Okay, so if the affinity is very big, so this value, this enthalpy value will be a large, because that means you need to have, you need a bigger energy to remove this electron. Okay, so electron affinity. So anyway, this statement is true. I hope you can understand that. And then if you go to the first ionization energy of these elements, fluorine, chlorine and neon, these are second period and third period elements as well. uh, you know, we can explain that one using our graph. Okay, so neon is a second period element and it's a noble gas. It will have the higher uh, first ionization value, neon here. And then the adjacent one, fluorine, and chlorine is in the lower period, so it should have a lower first ionization energy. So here the mistake, they have mixed up the places. So downward the group ionization energy decreases, so it fluorine should have a higher value. Okay, so you can write that review here. Downward the group IE1 decreases. Okay, downward the group IE1 decreases. IE1 decreases. Okay, then you can see the statement, the next one, metallic lattice stability. So this is going to be again wrong, because metallic bond strength depends on three factors. The factors are the number of free electrons, their charge and their size. Okay, so we discussed that same point I think in our 10th paper also, for the same elements. And sodium has only one free electron, magnesium 2 free electrons and aluminium 3 free electrons. So number of free electrons in aluminium is higher. And if you check the charges, same thing happens. Aluminium has a +3 charge, while others are having 1 and 2 respectively. And if you check the sizes also, aluminium has a smaller size, so aluminium 3 plus, right? And because of that, aluminium should have the best metallic bond out of these three elements, right? So then again C is going to be wrong. So let's write the proper order: sodium, magnesium and aluminium, because you can see number of free electrons are high, and their cation charge is also high, and the size of cation is low. These three factors are in favorable to make a good metallic bond. So if the metallic bond is better, metallic lattice, that means the solid will be stable. You can practically understand that one, because sodium is a soft metal which can easily be cut with a knife. Magnesium you can fold and bend and you can break it, right? But aluminium is a little bit stronger one than those two metals, so you can't cut aluminium with a knife. Understood that one? So like that, practically also you can think about this and get an answer, but this is the theory reasoning. So statement D about boiling points. So SO2 is a polar molecule which is having DP and London both. Okay, so these are the secondary interactions or intermolecular forces having here. And if you take carbon dioxide and neon, those are non-polar, and then they are having only London forces only. And if you take the difference, now both are non-polar, so carbon dioxide is a little bit heavier than neon, so its relative molecular mass is 44, while neon, as I remember, it is like around 20. Okay, so you don't remember relative atomic masses, you can get it using their atomic numbers. Okay, usually twice the atomic number is relative atomic mass, no? So its atomic number is 10, so it should be somewhere around 20, right? So then because of the smaller relative atomic mass, or you can see small number of electrons, you can say it's having lesser number of London forces. Okay, you can think about this one using electrons also, even though I write masses. Here London forces are low. So then this order should be correct. Okay, so if the secondary interactions are better, if the intermolecular attractions are stronger, right, boiling would be difficult. The boiling point is higher for SO2. So then your answer will be A and D correct. Answer 4. So that's the answer for the and the review for the 13th question. So I encourage you to again study these things: affinity, ionization, and metallic bond, boiling point. Those are facts that you are seeing in first and second units, which are very commonly asked, right? So I didn't went into full extent of explanations. I just took the facts, and I encourage you to go and read these and study these theories in your tute. Okay, right, and we did extensive discussions on these in our earlier papers, right? So about the 14th one, which statement is true about the oxidation states of compounds? Oxidation states. Only fluorine only shows -1 oxidation state in a compound containing F. Yeah, fluorine. If when fluorine makes compounds, it's always -1. That is a fact, right? That's true. Why? Because fluorine is the most electronegative element. So it's most electronegative element. So because when it makes a bond, always it grabs the electrons. Okay, so making it -1, right? So that's true. Oxygen mostly shows -2 oxidation state, so that also true because it's the next most electronegative element. Okay, so there are some exceptions for oxygen, even though we'll quickly write them down here. So if you take the compound, let's say H2O2, then your oxidation number is -1, not -2. Okay, and then if you join it with fluorine, then fluorine is more electronegative now. So then oxygen is going to be +1. Then there you have OF2, OF2. Then your oxidation number is +2. Like that, there are few exceptions, but mostly oxidation number is -2. Okay, so we use these rules when finding the oxidation numbers of other elements. Okay, like this. Now if you want to find the oxidation number of this carbon in this carbonate ion, so we use this mathematical method. We take this as X, unknown oxidation number, and here we assume that oxygen is -2 because it is usually -2, no? And then it is equal to the charge. We do the simplification, x minus 6 equal -2. We can get oxidation number of X as +4. So that's the method. That's where we use these points. Okay, right. And the C, in compound, oxidation state of group 1 metals is +1. Of course, that's also true. They also always +1 because they have this NS1 configuration, which by losing this one electron, they will get a noble gas configuration. So they always make +1 cations, and they always lose one electron. Okay, and then that is statement is true. You can see now 3 statements were correct. Then obviously answer is going to be answer 5. But let's see the last statement also. Anyway, in a compound, the oxidation number of an atom cannot be 0. It's wrong. Oxidation numbers can become 0 also. So we can point out this example. This is methanol, an organic compound you will learn later. And carbon is more electronegative than hydrogen. So it takes 2 electrons, partially attracts. And oxygen is more electronegative than carbon. So now carbon partially gain 2 electrons and carbon partially lose 2 electrons. So there is no electron exchange for carbon in this way, no? So therefore carbon oxidation number here is 0. Okay, so oxidation number can become 0. Okay, can't say cannot. So then that statement is wrong. Anyway, because of the 3 statements were correct, answer is going to be answer 5. Right, now we go into the next question. Out of the diagrams indicated below, which diagram is incorrect regarding the Hans rule? You know, Hans rule, this was a this similar to this question. There was a question in the 2024, the newest paper we had, A-level paper. So therefore, doing these model papers are very important. Don't forget to write a review also and repeat the questions once again. And Hans rule says when electrons are filled to degenerated sub-energy levels. What are these degenerated sub-energy levels? These are these things, like, so P has 3 orbitals, so it's a degenerated sub-energy level. So P, D, those are degenerated. Degenerated means that sub-energy levels C are broken into orbitals. So it has 3 p orbitals and D has 5 orbitals, like that. So when the electrons are filled to degenerated sub-energy levels, the electrons first filled singly, keeping the parallel spins, and then electrons are paired. Okay, so that's what Hans rule says. Okay, so you can write down the Hans rule by checking your book for the explanation purposes. So in that way, this one is true and this one is false because the spins are not parallel. Spin should be parallel when they form 1 electron per each. And again, first of all, electrons are filled singly, they're not going to be paired immediately, so that's wrong. And this one is also true because still the spins are parallel. Okay, don't put incorrect here because the spins are downward. It can be downward also. If one downward, others must also be downward. That's the thing. Okay, so A and D are correct. Answer is going to be 4. So write Hans rule here. Okay, so for the explanation. Right, so s orbitals are not degenerated, so therefore there's no such Hans rule is not applied for that. Okay, right. And in your A-level exam paper, 2024 paper, they checked Hans rule together with Aufbau principle. Aufbau principle, which electrons are first filled in the ascending order of the energy of the sub-energy level, which means you have to fill 1s and 2s first before filling 2p. That's the thing. So in that there was a similar question in A-level paper. You can go and see that one. They kind of messed with the Aufbau principle also. They put some wrong answers for Aufbau. That means they try to fill 2p without completing 2s. So that's wrong, no? Isn't it? According to Aufbau, 2s must be completed before filling 2p. Okay, so then study that too, and that's a good question. If when you are writing a review in your paper, in a different paper, please take the MCQ from 2024 A level. So I'll write it here, 2024 A level MCQ 2. Okay, so write it also here. You have a complete idea. Right, now the 16th question. The correct secondary interactions that exist in an aqueous solution of KCl. So look at the solution. It's an aqueous solution which contains water as well, and in that solution KCl is dissolved. So don't forget this aqueous part which tells it is having water. So between water molecules you have hydrogen bonds, that's true. Okay, so you can see between water molecules. So the compounds that have hydrogen bonded to more electronegative fluorine, oxygen and nitrogen will make hydrogen bonds. Okay, so then if you take another water molecule here, through the lone pair they will make a 5 bond. Sorry, not 5 bond, it's a hydrogen bond. I hope you understand that. Okay, so then what about the other things? So they are telling here regarding ion dipole interactions. Ion dipole. So there are two ions, K plus and Cl minus. They also attracted to water molecules. That's how they dissolve in water. They make ion dipole interactions with water. So telling that both K plus and Cl minus making ion dipole are true. Okay. So then answer is answer 5, and there is no dative covalent bonds in those are not formed. These are like ionic, no? K plus and Cl minus is ionic, but anyway that ionic bond doesn't exist in the aqueous solution, right? Because they dissolved, no? And separated. So each potassium ion is surrounded by set of water molecules. Okay, so you can draw some diagram here. Let's say this K plus, and it's surrounded by several oxygen atoms of water molecules, right? And they attracted, the negative poles of the oxygen are attracted to that, like this. So then the ions are separated, so no ionic bond exists here. So the why this question is so important, because most of the students are forgetting hydrogen bonds. Okay, so they take this ion dipole thing quickly, but some of them are forgetting this hydrogen bond thing. Understood? So that's how it goes. Okay, right. Now you go to the MCQ 70. The correct statement regarding alpha, beta and gamma radiation and cathode rays. Okay, so you can see cathode rays are also included. Let's check the statements. The path of alpha rays and gamma rays are changed by magnetic fields. So that is true for alpha, but for gamma is a neutral, no charge, no charge. So then if there are no charge particles, the path is not affected by electrical or magnetic fields. So that is going to be wrong for alpha. For gamma. Alpha, that is true. Alpha is a positively charged one, helium nucleus. So then it is affected by electrical and magnetic fields. In electrical field, alpha will bend towards the negative pole, and in a magnetic field it will bend perpendicular to the magnetic field, like other negative particles, right? But gamma doesn't change the path. They do not change the path. You can think about the beta as well. Beta deflects oppositely to the alpha rays, and cathode rays also charged particles, they are electrons. So similar to beta, they will deflect. In this year 2024 paper, they ask a statement regarding beta rays and cathode rays. So you students has to know how to know about this beta and cathode rays. They mean the same thing. They mean the electrons. Okay, remember that one. And the statement was for the 2024 A-level paper. You can write that too. Beta rays and cathode rays have similar E over M ratios. Okay, so that's the statement. That is true. Right. Second statement, the ionization power of gamma rays are extremely low. That's true, because gamma is very small and it has the speed of light in a vacuum. That also true. Gamma rays are electromagnetic radiations. Their ionizing powers are very low when compared to alpha and beta. Alpha has the highest ionizing power because it's very big, no? Alpha particle. So when it moves through the, let's say, a gas, it can knock out electrons very easily. Okay, because of the large size of the alpha particle. Then you go to the C. When an electrical field is applied on the path of cathode rays, those cathode rays do not deflect. When electrical field is applied in the path of cathode rays, those cathode rays do not deflect. So can't say no, wrong. It does deflect, like I was telling earlier. If they are charged, they deflect. So okay, wait, they do not deflect. Don't forget the last part. Perpendicular to the electrical field. Oh, okay, so yeah, that's true, no? The one that deflects perpendicular to the field is main magnetic field. Understood? In magnetic field they do deflects perpendicular, but in electrical field it's not perpendicular. So there might be a problem with this one. Some people may take this as wrong, because like I did seeing this part. So it's not only this, right? So there is a other part added here. This part you also have to add. Then think about the statements. Okay, so it's not deflecting perpendicular, it's deflecting towards. Deflecting towards. Okay, deflecting towards. Right. So then B and C are correct. Let's see the last statement. Penetration ability is beta is extremely high. So can't say extremely, it's higher than alpha because it's small, but it's lower than gamma. So telling extremely is high. Extremely high will be there for gamma, not for beta. Okay. So then B and C are the correct statements. Yeah, that means answer 2. As for the MCQ 17. Right. 18. The molecular formula AX4 has 4 AX sigma bonds. Okay. Right. So these are single bonds, that means, no? Single bond. So if you just draw it A like this, or you can just draw it in this way also. Tetrahedral. Or it can be like this as well. Remember this one, seesaw, that also applicable. Okay, and the A is the central atom. AX is a non-polar molecule. Oh, right. Okay, so what are the shapes I draw here? So this is seesaw, and this is tetrahedral, and this is no, this is then wrong. Wait, it's not seesaw. My mistake. I was thinking about the first one. Sorry, and that is actually a square plane because octahedral geometry, and there are 2 repulsion units perpendicular, so in a straight line here. So it's square plane. This is seesaw. Okay. This is seesaw. So seesaw is a polar molecule, right? It's not non-polar, but tetrahedral and a square plane, they are non-polar. So then answer is going to be this. T-shape you have only 3 repulsion units, so it's not going to work here. So other combination, answer is going to be answer 5. So let's explain taking one example why this one is non-polar. You can mark dipole moments and understand this. Fluorine is more electronegative, so electrons are pulled towards that, and you can see they all are in the same plane, 90-degree angle to each other, so they get cancelled. Okay, and there is a small dipole moment from the lone pair also, that also get cancelled because they are in the same straight line. Okay, so because of that, there is no net dipole moment. Mu r is 0. Repulsion resultant dipole moment is 0. Therefore, it's going to be non-polar. Okay, in that same way, you can understand tetrahedral is also a non-polar one. But seesaw, it's not non-polar because these 3 repulsion units are in the plane and one is lone pair, so it's not going to cancel out the repulsion in the dipole moments in the plane. Okay, so we call it as the equatorial plane, and the axial plane, the perpendicular one, their dipole moments will get cancelled. Okay, so it's other combination A and C. That's why answer is 5. Okay, it's a good question. Then if you go to the next one, 19. Which one of the following statement is correct with regard to NH3 and NF3? So it's a very common thing to ask in papers regarding this NH3 NF3 thing, because people get wrong here all the time. Okay, so let's review this and understand. NH3 with shorter bonds and large bond angles, NF3 in the other way, shorter bond angles like this. So NH3 bond angle is ළමයි 107 degrees, and this one 102 degrees. Okay, it's nice to know these values. Okay, right, bonded pair repulsions are weaker in NF3 than NH3. That's true, because the thing is, the bond electrons are more pulled towards fluorine. So then if you consider the curved distance, if you consider the distance among the bond pairs, it is higher for fluorine. Okay, it's higher for fluorine. It's higher for fluorine here. Okay, sorry, the distance between the, yeah, it's curved distance. Because of that one, the lone pair will push these electrons. But if you check for ammonia, nitrogen is more electronegative, so now their bonded electron pairs are very closer to each other here, so then they repel more. That's why the angle is higher. So with the angle we can understand that first statement is true. Bond pair repulsions are weaker in NF3. Okay, when bond pair repulsions becoming weaker, lone pair repulsion will become dominant and push the bond pairs away to get towards each other. Okay, towards each other, which making the lower bond angle, because we check the bond angles using bond pairs. No, NF3 has a higher dipole moment. That also a very common thing that you miss. It's true that fluorine is more electronegative, but once you draw the dipole moments, you will understand that's not possible. You can see the dipole moments are all scattered like this. Okay, so then the repulsion resultant is a lower value, a very low value. Okay, but if you consider NFH3, let's draw it and understand. So they all pointed towards nitrogen, and the lone pair will also pull above. So then sort of like they all directed upward. So then it's having a good resultant dipole moment. So don't get to the conclusion by thinking on fluorine. Okay, you have to think about the electronegativity differences and their arrangement also. So if you check the difference, actually nitrogen and fluorine difference is 1.0 electronegativity in Pauling units. Okay, and here just it is like 0.9. So their electronegativity differences are almost similar. Okay, so then you have to think about the angle and their arrangement of the dipole moments. So telling NF3 is more polar is wrong. NF3 has a higher bond angle, that also wrong as we discussed. And the last one, electronic differences are nearly equal. Yeah, that's true, nearly equal. So this is a past paper MCQ actually. I don't remember exactly the year, but it should be around 2011 to 2019. Okay, previous syllabus. But still the points are valid. Okay, these are second unit points. No, still very important. So answer is going to be A and D, answer 4. So let's check the next one. Sodium oxide and carbon dioxide. There's a reaction happening here. I'm telling few things. Let's check. During the reaction, carbon dioxide is converted to carbonate. Incorrect. Okay. The hybridization of carbon atom changes from sp2 to sp. That's wrong, because carbon dioxide, its hybridization is sp. You can see two repulsion units, linear geometry, sp. And to make two 5 bonds, carbons reserves its two p orbitals, two of the p orbitals. Okay, and one p orbital is remaining, and it hybridized with the s orbital. That's why it is sp hybridized. Okay, so when it goes to carbonate, this is the structure, and now it is trigonal planar. Now there's only one 5 bond, that means it is sp2 hybridized. So it changes from sp to sp2. Okay, from sp to sp2. So not the other way. So it's wrong. The bond length between carbon and oxygen increases, yes, and it is a double bond here, but now it is a single and double in between nature. So if you remember the resonance lesson, you can think about the resonance hybrid of carbonate, and it's having a partial 5 bond distributed, right? So if you further remember, the bond order of carbon oxygen bond here will be 1.33. Okay, so it's a when the bond order decreases, bond length increases. Okay, so that is true. In the product carbonate, all carbon bonds are equal. Yes, that's we just discussed. If you consider the hybrid, these statements are going to be true. Okay, so actually you must consider hybrid, okay, because that's the actually existing or the real structure. And the last one, the oxidation state of carbon atom changes. Yeah, does it? No, oxidation state doesn't change, right? Because it's not a redox reaction. One way you can understand, or you can just check the oxidation number. It's +4 here to consider the dipole moments, and here also carbon loses 4 electrons, so it's still +4. So it's a clever question, right? And they ask the incorrect ones. Incorrect ones are A and D, so answer 4. Okay, so that's the 10 MCQs, the review of 10 MCQ. I hope that's very important. There are very good points you can understand, and please check our earlier papers also. Okay, and write a good review. And now I'm going to show you the answers of the essays. I'm not going to write and discuss. I'll go to the answer scripts and share it with you. Okay, and this is our essay questions, and it is having 3 parts actually. First one is asking regarding a combustion reaction. C5H12 is completely combusted with some number of molecules of oxygen, and yeah, we have to find the moles. And first of all, if you follow the order, you will get the answers properly. First you need to give the balanced chemical equation, okay, and then the number of moles of C5H12, and you have the mass, you can divide it by the molar mass and find out the number of moles. And you can find the oxygen moles also by dividing the number of molecules by Avogadro constant. And then you can add ARR method, remember, and find out limiting reactant who's completely consumed, and thereby you can find out the mass of a carbon dioxide formed. And yeah, mole fractions, considering these are gases, you can find the mole fractions also. Okay, so I'll show you that one. Give me a second. Yeah, here we have the marking scheme. Okay, so you can see here the marks and how to find the answers. Just take a minute and go through there. Okay, first give the balanced chemical equation, and then the number of moles of the two reactants. Okay, right. And remember, it's very important, you need to show how to find the molar masses also. Okay, then you will have separate marks for that. And then this is how you use the ARR method, added reacted remaining. And since the molar ratios are 1:8, you have to just understand what is the limiting reactant, right? So to react with 1 C2H5 you need 8 O2. Okay, so then to react with 0.2 you need 1.6, then 8 times like that. So but we have more than that, no, oxygen, so then that means oxygen is excess. Okay, so like that you can understand. And that's our limiting reactant. Moles of carbon dioxide, 1 mole is produced, so grams are 44. And mole fraction, we can think like oxygen, water is also a gas in these conditions, because the temperature is 127, and I mentioned water as a gas in the data also. Here water exists as a gas. So therefore this is how you find the mole fraction. You add the total number of moles, remaining oxygen, formed carbon dioxide, and formed water. Okay, then you put it as a fraction. Can understand, no? So it's a good question. Try. Then the next one, the balanced equation for these reactions, and you have to use the inspection method here. And these are the reactants and products all given. And you can see the fourth and fifth questions, products are not given, because the thing is fourth one is a combustion reaction and fifth one is acid base reaction. That's why you know the products. During combustion all carbon is converted to carbon dioxide. During combustion all hydrogen is converted to water. So then you know the products and you can balance using inspection method, no? And acid base reaction also same. Acid and base react together to form salt and water. So you have to figure out the salt here. It is K plus and PO4 3 minus, cation and anion are there. Then you get the salt as K3PO4. Okay, because you need 3 potassium plus ions to counter the minus 3 charge of phosphate. And then once you know the salt, you can add the other compound, water. Okay, so I'll show you the answers of the balanced reactions. So these are the balanced chemical reactions. See, check your answers. And the thing is, you need to practice more with the inspection method, which you have to get the answers real fast. Okay, right. And then the next one, this is another acid base sort of titration question. The following is an experimental procedure for finding acetic acid concentration. Okay, acetic acid or vinegar concentration in a solution, right? And it takes 100 cubic centimeters and 50 of sample taken and 50 of excess 0.2 sodium hydroxide is added, and then 75 of that is titrated with HCl to find remaining sodium hydroxide. Okay, so here's the theory you have to understand. I'll give you a small diagram for this one. Yeah, you have 100 cubic centimeters of this acetic acid sample. Okay, and then you add 50 cubic centimeters of sodium hydroxide, and it is telling excess. That means you have sodium hydroxide enough to completely react with acetic acid, and the concentration of that is 0.2. Okay, and then there's a reaction happening. Sodium hydroxide is completely acetic acid is completely reacting with sodium hydroxide. Some sodium hydroxide will remain, okay, as it is telling. So this is your salt and water. Okay, and the remaining, now you have the solution. And now that solution you had, this is the point where most of students are forgetting. Now this is the total solution, and it has some remaining NaOH, because here 50 and here 100. That's how it become 150. And you are taking 75 portion of that one, 75 cubic centimeters. Okay, and you titrate with that 75 cubic centimeters. That means you take the half of that to find the remaining sodium hydroxide. So from this 0.1 HCl, 10 cubic centimeters were consumed. So then you can find how many moles of NaOH is remaining. Okay, and then you can work on the separation and go back and find how many moles of NaOH was there actually in 150, and that's the remaining moles of NaOH. Okay, so that's how you find the concentration of acetic acid. And there is also another acid base reaction happening, HCl and NaOH, this one. So I'll show you how to get the answer here quickly. So HCl, you get, if you multiply the moles by concentration by volume, you get 1 into 10 to the power minus 3 moles. Okay, so you have 1 into 10 to the power minus 3 moles of HCl. That means NaOH also same number of moles are there. That is remaining in 75. So in 150 you will have twice like that, 2 into 10 to the power minus 3. And how many NaOH moles you added here actually? It's like 50 to 10 into 10 to the power minus 3 like moles. That means the reacted ones is the difference. So 8 into 10 to the power minus 3 has reacted. That means 8 into 10 to the power minus 3 acetic acid is there because they are reacting 1:1 ratio. Then when you get the concentration, you have divided by the volume. That's it. Okay, right, I'll show you the proper way to write the answers. Now this is some sketch now and working roughly, and this is how you're going to get the proper answer. See the diagram, guys? Understood? And first find the HCl moles and then write the reaction, show the ratio. Right, and this is the NaOH remaining in 75 and you work out to get in 150, and added NaOH and reacted, you can find reacted with acetic acid, this one, and then you write the acetic acid reaction, same flow. Okay, you have to write them, that's the thing. You can see in earlier one I just wrote here and there, no? But it's not going to work in essay. You have to write properly the steps in this order. Right, add some words also. Okay, you can see each one is given marks, each step. And expressing the molar ratio is also important. I have to say it is 1:1. Okay, that also given marks. And this is the concentration of acetic acid, 8 into 10 to the power minus 2 moles per decimeter cube. And did you notice they are asking another question here? They are asking express the composition of acetic acid in ppm. So if it is a very dilute solution, we can say 1 mole per 1 milligram per decimeter cube is equal 1 ppm. That relationship we can take this to write in that, you get some marks, and then you get the molar mass and you find the number of moles here, mass here, and then you put it into milligram, you get 4800. So then if you express that one in milligram per decimeter cube units, there you have your ppm value, 4800 ppm. Is that clear? Okay, that's how you get the ppm value. Okay, so by assuming it is a very dilute solution. So just remind the previous things we did. There is another way of finding the ppm value by telling mass fraction into 10 to the power 6. Okay, you get the mass fraction of acetic acid, okay, by getting the total sample mass and the acetic acid mass, then you get the mass fraction and you multiply it by 10 to the power 6. When you get in the total mass of the solution, you have to assume it's a very dilute solution and take the density of the solution as 1 gram per cubic centimeter. Okay, think we did some questions from that one. Yeah, and this is the shortest way to understand and get the answer. But both methods are true. When you are writing the review, please write the method I just mentioned by finding mass fraction of acetic acid and multiplying it by 10 to the power 6. That also very important. Okay, so that's how we get the answers for the questions. I hope the essay questions won't be a problem. You have the marking scheme in the in this one recording. Mark your answers with that, and put some marks or put the marks also. And it is like 100 mark question, essay question, and you have 10 MCQs also. And then divide the marks of the essay question by 2. That means you get out of like 50 marks. Now out of 50, how many for essay? And then give, there are 10 MCQs in this today's discussion, and give 5 marks for each MCQ. Then you have another 50 marks, and then add them and get a mark for the paper 11 out of 100. Okay, right, and write a good review as always. Keep them with you, repeat them, practice them, read them again. Okay, then be confident about the first 3 units. Okay, you guys can do this one. You can get a very good results in these A-level exams. Okay, right. So if you have further doubts regarding any of the questions, or especially in the essays which I showed you the markings, and you can ask them in the class also. Right, then see you again with our next paper discussion. Study well and write a good review. Okay.